Welcome, my dear students. Now, natural radioactivity, second part. We have already discussed about heavy element. Now, I have given the definition of heavy element. You can write down this. The atoms of element having mass number greater than 206 and neutron-proton ratio 3:2 approximately is called heavy element. These elements normally exhibit the character of radioactivity. That is, the mass number of heavy elements will be greater than 206. Say uranium. Uranium has 4 isotopes having mass number 235, 236, 237, 238, etc. And it has atomic number 92. Now 235 minus 92, 143. So neutron 143 and proton 92. It is approximately 3:2. It is greater than 3:2. 92 and 138. If 138 neutron is there and 92 proton is there, then neutron proton ratio 3:2. But there is neutron 143. So this is heavy element. In case of the ordinary elements, say oxygen 16, 8O16, 8 protons and 8 neutrons are there. Neutron proton ratio 1:1. Say chlorine 35, 17 proton and 18 neutron. Neutron proton ratio is nearly 1:1. But in case of the heavy elements, neutron proton ratio is 3:2. This is neutron proton ratio 3:2. Now, the second criteria is that its atomic number is greater than 206. So these are the heavy elements. Examples of heavy elements: uranium, radium, polonium, plutonium, etc. And this polonium was invented by Madame Curie. In this context, I want to say the story of Madame Curie. Madame Curie actually got Nobel Prize for 2 times. She is the only person who has got Nobel Prize for 2 times in physics and chemistry. For the first time, she got Nobel Prize with her husband, Pierre Curie, for invention of polonium. And this Nobel Prize was given for chemistry. Now, Madame Curie invented polonium. Polonium is one of the radioactive elements. Plutonium, radium, etc. are the radioactive elements, and all have the mass number greater than 206. Now, this is about our heavy elements, and keep in your mind that these heavy elements, as a natural character, when they are kept in any place, in any condition, under any effect, under any influence, radioactive emission takes place. Radioactivity will not be prevented by any application. Now, radioactivity is a natural phenomenon. We will go through this. Radioactivity is totally a nuclear phenomenon. It is not at all related to the extranuclear electrons. Radioactive radiation takes place from the nuclear part of the atom. Now some arguments in favor of nuclear phenomenon of radioactivity. Radioactivity involves nuclear phenomenon. Now, in the first point I have written, due to spontaneous disintegration of heavy nucleus, radioactivity takes place. Nothing like application of heat, pressure, catalyst, magnetic field, electric field, etc. can prevent radioactivity. At what place, under any condition, you keep radioactive elements, like certain quantity of uranium is kept in a drawer or is kept in a hole, is kept in any place, radioactive emission will take place, and this cannot be prevented. And the second point is that even these beta particles are actually analogous to electrons. So, one beta particle is equivalent to 1 electron. And I have already stated that electrons in the form of beta particles are emitted from the nucleus of heavy element. How are the beta particles emitted from the nucleus? Actually, 1 neutron is a combination of 1 proton and 1 electron. And 1 proton and 1 electron neutralizes its charge, and when beta particles are emitted, before emission of beta particles, neutron splits up into proton and neutron. Leaving the proton, electrons are emitted from the nuclear part, and therefore the atomic number of the element is increased by 1, because instead of one neutron, a proton take part. Therefore, number of proton is increased by 1, so atomic number is increased by 1. But mass number is the sum total of protons and neutrons. Now, keeping the proton, electron is emitted, so instead of one neutron, one proton is there, so mass number remains unchanged after emission of one beta particle. So I have written even the beta particles analogous to electrons. Beta particle is equivalent to electron, but it is emitted from the nuclear part. It is not emitted from the extranuclear part. So there is no relation between radioactivity and extranuclear electrons. It is totally nuclear phenomenon. And the third point is even radioactivity retains in the compound formed by the radioactive elements. Actually, we know in normal compounds which are formed by the reaction of electrons, by the role of electrons, by whatever may be, by electrovalent bond, by covalent bond, etc. The electrons play their role for formation of the compounds. And in those compounds, the properties of the components, properties of the basic materials, say in water, properties of hydrogen and oxygen do not retain. But in the radioactivity, in the radioactive elements, radioactivity retains in those compounds which are formed by radioactive elements. Say in a compound of uranium is present. The radioactivity also retains in that compound formed by uranium. This happens actually as it is a nuclear phenomenon, as it is not simple electronic phenomenon. So it happens. And again we can say that due to radioactive emissions, the atomic number of the element is changed and new element is formed. So in case of the electronic property, no new element is formed from one element. After radioactive emission, new element is formed. Atomic number is changed as it is nuclear phenomenon, so it happens. So these are the arguments behind the point radioactivity is a nuclear phenomenon. And keep in your mind that if one alpha particle is emitted from a radioactive nucleus, then its mass number is decreased by 4 and its atomic number is decreased by 2. And if one beta particle is emitted from a nucleus, radioactive nucleus, its atomic number is increased by 1, keeping mass number unchanged. And when gamma rays are emitted, gamma rays, as they are radioactive, as they are the electromagnetic waves, and as there is no massive particle, therefore no change of mass takes place in case of gamma rays emissions. No change of mass number, no change of atomic number takes place. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.